All right, guys, we're wrapping up towards the end. We're on chapter 6-6. Today we're talking about Moore's Law. You guys are going to have one more day on Monday where we will have in-class or video lecture, and then on Tuesday you guys will have your test for chapter 6. Okay, so let's jump into what is Moore's Law. The question for today is, what is a fair price for a computer? We're going to talk about that because it will apply with what Moore's Law is. So what I want you guys to do is I want you to go ahead and write out, describe what you think has determined the price of computers over the years. Like, what do you think? Is it supply demand? Is it what actually goes into making a computer? Describe what you think has determined the price of a computer over the year. Pause me and then come back in a little bit to continue out. All right, now that you've done that, let's go ahead and go over some of our review questions. So what was the name of the code-breaking machine that British scientist Alan Turing created to break code in World War II? That would be the Colossus. What is the name of the first microprocessor that was created by Dr. Ted Hoff? That is the i4004. What made the UNIVAC 1 popular? It uh, it predicted the Eisenhower election. Forgot my words there. And what was the name of the first computer virus? That is Elk Cloner. Now, some other ones that are not on your worksheet, I'm going to go ahead and go over, though. Remember, if I go over it multiple times, I'm probably going to see it again. What is the honor that the computer received from Time Magazine? Time Magazine recognized the computer as the machine of the year in 1983. The most basic unit of computer memory is a bit, spelt B-I-T, a bit. What is considered the earliest computer by some? That is the abacus. Who is the father of the computer? That is Dr. John V. Attensoff. He created the ABC computer with his partner Clifford Berry. Dr. Grace Hopper is a woman that is best known for her being a pioneer in the field of coding. Ansoff invented what computer? We just talked about that. That is ABC. The backbone of the computer is considered the motherboard because it connects everything. And compare and contrast solid state drive and hard disk drive. Remember, solid state drive is more compact, more expensive, but generally faster, less likely to break, where a hard disk drive is generally larger, holds more storage, but has more moving parts, a little bit cheaper, and is more likely to break because of having more parts. All right, now we had talked about Frontier, which is now the world's fastest supercomputer, but previously it was Fugaku. All right, at the time I first started it, it was being used to help with COVID research, watch and create spread simulations, and come up with ways to diagnose and therapeutics for COVID. Now, Frontier. All right, this is currently the world's fastest supercomputer. It is located here in the U.S. in Tennessee, created by HP. It is currently being used for a wide variety of things. If you look it up right now, it will actually give you a lot. So like modeling Milky Way, if you're talking about deep space and different things like that. But some things it does is it'll model climate changes and potentially different outcomes, investigate disease origins, such as like with COVID, and patterns in medical data. So it is used to kind of keep an eye and track a lot of things like that in a lot of simulations. So one cool thing, it can do 1 quintillion calculations per second. I don't even know how to do that. So if each person on Earth, or to describe that, if each person on Earth completed one calculation in a second, it would take more than 4 years to do what Frontier can do in 1 second. It takes 6,000 gallons of water moving through, all right, to keep it cool, okay? That means it would take 30 minutes. It's moving so much water that it takes 30 minutes of Olympic-sized swimming pools to kind of get through, okay? It uses a lot. Read through this is actually very interesting. Now, this is kind of cool. It uses the mechanical plant used to cool Frontier, to keep it cool, keep everything going, not overheating, would be the same for what is demanded to power 30,000 homes. So it is cool that we have it, but it does use a lot of power. All right, now, warm up number 2, what I want you guys to take a second, and I want you to go ahead, and I want you to look up and describe in your own words what is Moore's Law. Okay, we'll come back to that. All right, so what is Moore's law? Hopefully you've looked it up by now. Moore's law is the observation that the number of transistors on a dense circuit board will double every 2 years. So number of transistors will double every 2 years on a circuit. That is Moore's law. Now, why does that matter, right? Gordon Moore is the guy who introduced this law. He was born 1929. He is currently worth $9.3 billion, and he graduated from, last time I looked, I think he actually passed away not that long ago. But anyway, he graduated from California Institute of Technology. Now, this guy is well known for who he is. He is known, so who is Gordon Moore? He is the co-founder of Intel. Now, before he created Intel, he actually worked. So, what was he working on before going and working for William Shockley? He worked on anti-aircraft missiles, right? But we'll get into a little bit more of that. So, transistors, when we're talking about Moore's law, is that the number of transistors are going to double on a circuit every 2 years. So what is a transistor? It is a device that is used to amplify or switch electrical output. Sorry, I'm looking back and forth. I'm making sure I don't skip your questions here. And we're going to talk about how to describe a transistor in a little bit. So Intel, when we're talking about Gordon Moore founded Intel in 1968. He is a co-founder of Intel. Previously, before that, he worked for a guy named William Shockley. Before he worked for William Shockley, he did anti-aircraft missiles. So what was he working on before going to William Shockley? Anti-aircraft missiles. And then he went to work for William Shockley, who created the Fairchild Semiconductor Company. But him and some of his buddies actually left to go create Intel around 1968. And William Shockley referred to them as the traitorous eight. So what did Shockley refer to him and the 7 other people that left? They were known as the traitorous eight. Now, what is a transistor? A transistor is a binary switch. Now, if we remember, binary refers to 2 numbers. The best way to describe a transistor is, I like to think of it as an open and closed gate. So, for example, if you think about for your computer, the keyboard, simple example. If you press the space bar, it adds a space to your document. If you don't press the space bar, nothing's happening. So a transistor is either an open or closed gate. If it's closed, you're getting a response. If it's open, nothing's happening. All right, and that's kind of how a computer operates. It's either open or closed, and based off what gates are open and which gates are closed, different outcomes, different outputs. Okay, so that's how I would do it. So who founded Intel? Intel was founded by a guy named Robert Noyce and Gordon Moore in 1968. All right, Robert Noyce, Noyce, and Gordon Moore. All right, Moore's Law was first published. He's really well known for Moore's Law. All right, Gordon Moore, that's what he's known for. But aside from co-founding Intel, but he's really well known for Moore's Law, which was published in the 1995 edition of Electronics, this magazine. And they were simply asking it. He didn't do it on purpose. It wasn't on intentional, but they asked him. They're like, all right, what do you think is going to happen over the next few years? And originally when he stated it, he said every year the number of transistors on a circuit are going to double. But as things changed and got into got later on and things got more complicated, my bad, I said 1965 magazine, Electronics magazine. But as things moved on, he said every 2 years, not just every one. Now, he also said in Moore's Law what we can expect. He expects if there's more transistors that we can expect the speed and capability to be faster and that we should be able to pay less for it, right? Now, that is why that it says in there, are we affected by Moore's Law? He stated it, we can expect and perceive these things, but however, I think because the supply and demand curve, that does more of it, right? We may see, oh, wow, our computers are getting smaller, they're getting faster, but because of the demand curve, right, we're actually getting to where I think Moore's Law is kind of off to the side. It doesn't affect us in what we actually pay. Okay, those are some things to kind of think about. All right, what did Moore think? Will his idea, his theory, last forever? Well, originally he said it would last forever. However, when talking to him in the early 2000s, experts agree that Moore's Law will come to an end. And they expect it to come to an end by really the end of the 2020s. And this is because fundamentally the building blocks of matter are atoms, right? You cannot get smaller than an atom. If you split atoms, you get nukes, right? So will Moore's Law end? The answer to that is yes, it will. Eventually, you cannot continue to get smaller and make those transistors any smaller than actual matter. Okay. So now, next thing you guys are going to do, you guys are going to play this video and answer the 3 video questions you have there. All right. And I'm going to skip through. You guys can get those questions. We're going to go back and we're going to hit on operating systems again. All right, so a definition for operating system. We've talked about it. It is the user interface that you guys are going, or that you use when you're using a computer. But a better definition for everything is a set of programs that coordinate all the activities among computer and mobile device hardware. Some examples of operating systems we've talked about already. We've got Mac OS, we've got Windows, we got Linux, we got Chrome. All right, so those are your first 2 answers there. All right, what does an operating system do? It does quite a lot. It does all of these things, but I like this picture here. So if you look, 5 things, or 6, my bad, 6 things that it does: starts up and shuts down computers. It provides the user interface that the user, interacts with, coordinates different tasks, establishes internet connection, file management, and also offers automatic updates. So those are your 6 things that a computer functions of an operating system. Does an operating system have to be found inside a computer to work? The answer to that is no, actually. We're going to talk about the difference in some ways, but technically it can be on a flash drive. Are operating systems created for certain computers or purposes? Generally, the answer to that is yes, right? Operating systems, you think about even your Xbox. It has its own operating system, and it works on the Xbox. It doesn't work on the PlayStation unless you kind of jailbreak it and kind of go around some loops to get there. Okay, when we're talking about this, there's a couple definitions you need to know. For example, I wanted you guys to define what a platform is. A platform is simply described as the operating system that a computing device uses. So a platform is the operating system a computing device uses. Cross-platform applications are applications that can be used on multiple operating systems. So I like to think of the idea of Apex, Call of Duty, or Fortnite. You can use and play those same games across different platforms or operating systems. Booting a computer. All right, there are 5 steps. Booting is just starting up your computer. And so 5 steps to booting a computer are, all right, first of all, you're going to turn on the electric. All right, so you're going to press a button and turn it on. The first step, turn on. Electrical charge is sent throughout the computer, which kind of wakes up all the parts. All right, the second part, that electric charge presses the kind of a reset button, and it starts startup instructions. So step 1, turn it on. Reset and startup instructions start. This is the step 2. Step 3, startup and self-check test are ran. Step 4, the kernel of the operating system, which we'll talk about in a second, provides instructions to RAM, loads to RAM. So the kernel loads to the random access memory. And step 5, user sign in. So once again, turn on. All right, electrical charge is sent. Step 2, the startup instructions are started. Step 3, self-check test. Step 4, the kernel is loaded to RAM. And step 5, user login. All right, what is a kernel? The kernel is the main bridge. It is what works between hardware and software. Okay, that is very important to know, that the kernel, what I want you to know, is the main bridge between hardware and software. Now, there's 2 different ways to start your computer. There are 2 different types of boots, so to say. You got a warm boot and a cold boot. What do you think is faster, right? If you think of anything in science, the warmer it is, the faster it is. So a warm boot's going to be faster. But all the difference you need to know is a cold boot is starting up from off. If your computer is completely powered off, nothing to it, and you start it up, that is a cold boot. A warm boot is simply restarting your computer. Your computer stays on the entire time. It is never cut off. All right, we're on our last page here. What is BIOS? All right, this stands for Basic Input Output System. All right, it is the first system that is ran when powered on, and this is what allows your computer to take in information from different things. So make sure you guys are aware of that. Last thing you guys are going to do, you guys are going to do a little bit of research to finish your worksheet, and you guys are going to research and find 2 operating systems that are used for cell phones, 2 for laptops, and 2 for tablets. Be sure to add your sources under the section here by citing your sources using EasyBib.